For this example, we want to use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. For this example, g of x is equal to 1 over x minus 1 plus 5. Our function is g of x equals 1 over x minus 1 plus 5. For our basic graph, we have y equals 1 over x. And I can tell that that is our basic graph because I have a variable x in the denominator. I've got 1 over x. The graph of this basic function has a vertical and horizontal asymptote. So it has a vertical asymptote that's right on top of the y-axis. It has a horizontal asymptote that's right on top of the x-axis. And the graph itself looks like this. We have some transformations. And the transformation that we have is a minus 1 and a plus 5. These transformations are both shifts because they're adding and subtracting. The minus 1 is a horizontal shift because it's inside the fraction. The plus 5 is a vertical shift because it's outside of the fraction. Horizontal is left and right. The minus is right. We're going to move to the right one. And the plus 5, being a vertical shift, is either up or down, and because it's plus, it's up 5. I mentioned the horizontal and vertical asymptotes because those will help us shift drawing the graph. So my horizontal and vertical asymptote meet right here at the origin at 0, 0. I'm going to shift to the right one and up 5 to shift the location of where the vertical and horizontal asymptotes are. So if I shift to the right one and up 5, that's going to be the location where the vertical and horizontal asymptotes cross each other now. So my vertical asymptote is now going to pass through x equals 1, and my horizontal asymptote will pass through y equals 5. So by shifting where the asymptotes are, that is shifting the graph itself. So my graph will look like this. So it's the same graph, just shifted around the point 1, 5 instead of around the point 0, 0. The graph to the right was created by using one horizontal shift and one vertical shift of the graph of the basic function y equals absolute value of x. Write the function that describes the graph to the right. So we are given this particular graph of an absolute value function, and we want to write the equation of that function using one horizontal shift and one vertical shift. So it's helpful if we know what the original graph looks like. Y equals absolute value of x does have this V shape that our picture does, but the turning point that we see here, really it's like a corner where the two lines meet each other. That corner is happening at the origin, which is at 0, 0. So if we pay attention to that corner and where the new corner is, that's going to be helpful in understanding what our vertical and horizontal shift are going to be. So what we notice is that from our origin, this new point is shifted to the left 1 unit and down 3 units. And so we want to make sure that our equation reflects that shift, that horizontal shift of left 1 and the vertical shift of going down 3. Now, in order for us to know what the equation looks like, we'll have had to study horizontal shifts and vertical shifts and have some facts memorized. So what I did is I pulled up this flowchart that I created to help us memorize the information that we need to know about shifts in order to write our equation. So one thing that we need to know is that in our equation, the shifts are going to be added and subtracted numbers. And then vertical shifts are going to be added on the outside, and horizontal shifts are going to be added on the inside. So our horizontal shift is going to shift to the left, which means that we're going to add our 1, remember it was 1 unit to the left, and our vertical shift is a shift down, so we're going to subtract by 3 to shift down 3 units. So that down 3, that subtraction is going to be on the outside because it's a vertical, and plus 1 is going to be on the inside of the absolute value because this is a horizontal shift. So let's go back to our problem, go back to our picture. And our base equation is absolute value. And on the inside, we want to do our horizontal shift, which we're going to do a plus 1 to do a shift to the left 1. And our vertical shift is going to be on the outside, and it's going to go down 3, so we subtract. So this is our horizontal shift, and this is our vertical shift. And this is our equation of the graph that we have on the right. Absolute value of x plus 1 minus 3. In this example, we have let f of x equal square root of x plus 1 and g of x equal x squared minus x. We want to find and simplify the expression. Our expression is f minus g of 8. I have 2 different ways that I can work this problem out. I'll show you the first way. In the first way, we can understand what these symbols mean, that we want to evaluate f at 8, evaluate g at 8, and then subtract the 2. So f of 8 would be substituting an 8 into the function named f. That's square root of 8 plus 1, which is square root of 9, which is 3. We want to evaluate g at the value of 8, so we're going to substitute 8 into the function named g. That's 8 squared minus 8, and we need to make sure we subtract that whole expression. We're going to subtract 64 minus 8, and 64 minus 8 is 56. 3 minus 56 is negative 53. That's one way to find this expression, the value of this expression. Another way to find it, if you have f minus g of 8, you would first build the function f minus g of x. That function is f of x minus g of x. That's square root of x plus 1 minus the whole function g of x, x squared minus x. That's square root of x plus 1 minus x squared plus x. And so we've found the function f minus g, and then you would evaluate by substituting 8 into that function. F minus g of 8. That's square root of 8 plus 1 minus 8 squared plus 3. Sorry, not 3, 8. And then we'll simplify. 8 plus 1 is 9. 8 squared is 64. Square root of 9 is 3. Negative 64 plus 8 is negative 56. And 3 minus 56 is negative 53. So we have two ways to find the solution for this problem. On this example, we've been given a picture of two graphs. We have the graph of f written in red here. This is a very interesting graph. It has a feature you may not have seen before. This is called a cusp. It's where it kind of comes to a point and curves out. Looks kind of similar to an absolute value graph, but you can see that the line is curvy instead of straight. In this blue graph, we have a straight line, and that is labeled G. So this curvy one with the cusp is labeled F, and the straight line is labeled G. And on the left here, I have some examples that we're going to work through. We have f plus g of 16. And we're going to simplify this. What this notation wants us to do is to evaluate f at 16, evaluate g at 16, and then add the results together. So I want to identify an x value of 16 on f and an x value of 16 on g. So over here on the right hand side, I can identify on the graph of g a y value of 3, so that's 16, 3. And then on the graph of f, that looks like 16, 4. So I'm identifying the y-coordinate on both of these. So f of 16 would be 4. G of 16 would be 3. And I want to add those results together to get 7. So let's continue on to the next part. We have f minus g of negative 16. And I'm going to evaluate f at negative 16, evaluate g at negative 16, and then subtract the answers. I'm subtracting the answers because of the subtraction in my function notation. So I need to identify an x value of negative 16 and find the y for f. An x value of negative 16 on g and find the y. So over here on the left hand side, I've got this ordered pair, which is on G, and that is the ordered pair -16, 1. And this value right here is on the graph of F, and that is -16, 4. So F of -16 is 4. G of -16 is 1, and I want to subtract those values, and that gives 3. In the next example, I want to find G times G of 16. This is the same thing as G of 16 times G of 16. We've already identified G of 16 to be 3. So this is 3 times 3, which is 9. So we notice that we're doing multiplication here because there's multiplication in the function notation. And then finally, we want to do f over g of 1, and that is f of 1 divided by g of 1. So we've got division here. We're doing division of our individual functions. So f of 1 would be right here. This is the ordered pair 1, 1. And g of 1 doesn't look like it gives us a nice number. Okay, so what I've noticed here is I wrote the problem wrong. I wrote this as f over g of 1. It should have been f over g of 16. So let me make that correction. So this is f of 16 divided by g of 16. And we've already found f of 16 to be 4 and g of 16 to be 3. When we divide those, we get 4/3. So f divided by g of 16 is 4/3. We have for the pair of functions defined, find f plus g, f minus g, f times g, and f over g. Give the domain of each. So we're given our f of x. We're given our f of x to be x squared minus 1, and our g of x to be 5x plus 20. So we are going to find f plus g of x. That's going to be f of x plus g of x. That's x squared minus 1 plus 5x plus 20. And we're just going to combine like terms to get x squared plus 5x plus 19. And we've just found our function f plus g. And we're going to find f minus g of x. That's f of x minus g of x. You have to be a little bit more careful with subtraction because we want to make sure that we're subtracting the whole function. So f of x is x squared minus 1. We're going to subtract g of x. I'm putting parentheses around g of x. That's 5x plus 20. We have x squared minus 1 minus 5x minus 20. And we'll combine like terms to get x squared minus 5x, and then negative 1 and the negative 20 combine to be negative 21. So then we're going to multiply, that's f times g, by doing f of x times g of x. f of x is x squared minus 1, and g of x is 5x plus 1 plus 20, and we want to multiply them. So once again, we have to be careful here because we want to multiply all of f by all of g. So we're going to put parentheses so that we multiply all of it and also that it represents multiplication. So when we multiply, we're going to do x squared times 5x, that's 5x cubed. X squared times 20 is going to give me 20x squared. Negative 1 times 5x, it's a minus 5x, and negative 1 times 20 is a minus 20. We don't have any like terms there, and so we won't combine them. So then finally, we're going to find f over g of x. So we're going to put f of x in the numerator and g of x in our denominator. F of x is x squared minus 1, and g of x is 5x plus 20. When we simplify these fractions, we want to make sure that we're reducing it to lowest terms, canceling out any common factors we might have. Our numerator is a difference of squares and can be factored into x plus 1, x minus 1. And our denominator has a greatest common factor of 5. If we factor that out, we get x plus 4. And there are no common factors here, so our rational function is in lowest terms, f over g. We want to come back here and find the domain of each one of these functions. And when we're finding the domain of functions that we add, subtract, multiply, and divide, we have to first consider the original domain. Because if we're using these functions to put together the new functions, we have to have, at the very least, the same restrictions. So both of these functions are polynomial functions, and polynomial functions have a domain of all real numbers, negative infinity to infinity. So the domain of f will be negative infinity to infinity. The domain of g will be negative infinity to infinity. So when we add, subtract, or multiply, because we're having polynomials, they create polynomials. So if you have two polynomials and you add, subtract, or multiply them, you're going to get a polynomial. So all of these new functions have a domain. I'm going to say domain of f plus g is also all real numbers because these are polynomial functions. Domain of f times g is negative infinity to infinity. And domain of f minus g is negative infinity to infinity. Now the division is different. Now when you introduce division, you have now created something that is not a polynomial. This is a rational function. And with rational functions, our denominator cannot be 0. So we're not going to have a domain of all real numbers for the division. We need to take the expression in the denominator, which is our g of x in this example, and set it equal to 0. And we solve, we get 5x equals negative 20, divide by 5, and we get x equals negative 4. That negative 4 is a restricted value because it's going to cause the denominator to equal 0. So our domain here will be everything, all real numbers except for negative 4. And we write that in interval notation. Let me zoom out so I'm not losing part of my question here. Our interval notation will be negative infinity to negative 4, union with negative 4 to infinity. And that's the domain of f over g. Thank you for checking out my videos. Have a great day.